And welcome back. So now we're going to talk about bone formation. So what drives bone formation, as well as what are the types of bone formation and how do they occur? So the formation of bones in a nutshell is osteogenesis. And this is going to occur early in embryonic development. So you are forming bones or you start forming bones before mom has missed her second period. That's kind of, an interesting insight. And bone formation occurs throughout, starting at about week 8, and it doesn't end ever. You continue forming bone, you continue modifying your bones. So you're going to strengthen your bones or weaken your bones even in adulthood. But bone growth itself typically ends around once you hit adulthood, between 18 and 25 years of age. There are two types of bone formation: intermembranosus ossification, which is not as common form of ossification, but it still does start during embryonic development. And then we have endochondral ossification that occurs, and it's a little bit more complex. And that's the one that typically works or occurs throughout the entire childhood to adulthood formation, okay? So let's look at intermembranosus ossification first. So this form of ossification is what makes up the cranial bones of the skull. So your frontal bone, parietal bones, occipital bone, temporal bone. It also makes a portion of the clavicle. And the precursor connective tissue to this bone formation is called mesenchyme. So mesenchyme is the precursor to all connective tissues, and you have mesenchymal cells that start thickening or coming together in a region where we will call the ossification center. And some of those mesenchymal cells then become osteoprogenitor cells. Osteoprogenitor cells are your bone stem cells. And so these osteoprogenitor cells will produce new osteoblasts, and some of the mesenchyme will become osteoblasts. So some of the mesenchyme forego the osteoprogenitor step and basically go right into making osteoblasts. And the osteoblasts then secrete osteoid. So now we have osteoprogenitor cells as well as osteoblasts in this region. Osteoprogenitor cells will produce new osteoblasts. Osteoblasts will produce osteoid. The osteoid in that region is going to undergo a calcification as calcium salts, so calcium phosphate, settle in. Once you have that calcification step, the osteoblasts become osteocytes. And osteocytes are what maintain that bony matrix. So now we have this woven bone that's pretty much the same as or similar, I should say, to the spongy bone. And a periosteum will start to form along the edge. So periosteum is formed by that mesenchyme again. Periosteum is composed of dense irregular connective tissue. Mesenchyme is the precursor to all connective tissues. And so it thickens along the edges, both edges, and becomes the periosteum. Blood vessels move in to the bone itself. And then the woven bone, the lightly produced woven bone is going to be replaced by your spongy bone. So woven bone, very similar to spongy bone, basically not as compact or not as protective. And so here you have this spongy bone here, or lamellar bone here, and that is how your cranial bones are formed. And I'm going to click on this, and you can actually see, I'm not going to play the video, but I will click on the video so you can see. Not always do these videos. Sometimes these videos don't play well. That's why I'm going to let you play it on your own. But I'll click here, and you can see what I'm seeing. Do you see what I see? It's not Christmas time, I know, but I'm hoping that, okay, so here's the video. If it shows up.
Hello,
there you go.
my name is Bruce Closer, and this animation is demonstrating the biological process of intermembranous ossification.
So you can watch this and then come back to the lecture, okay? The next form of ossification, and the more common form of ossification, is endochondral ossification. So it's kind of interesting. The majority of, at 8 weeks in utero, we have a body, right? We have all the makings of a human. Our bones are forming, but the majority of our bones are composed of cartilage, so they're not actual bones yet. It's a cartilage skeleton. But through endochondral ossification, the cartilage is going to become bone. And so during the embryonic period, we have mesenchymal cells that differentiate into chondroblasts. Chondroblasts produce chondrocytes, so they produce the cartilage matrix and become chondrocytes. And then you have this cartilage skeleton, okay? And so that's what this is here, just showing that cartilage skeleton. When you have this cartilage skeleton, some of the cartilage in the structure will start to hypertrophy. So as they're growing, they start to get too large and they will burst. And that bursting releases chemicals. Those chemicals cause calcification. Bone is highly vascular and so can be in a very hard area because there's blood vessels that run through the bone. Cartilage is avascular, so it has no blood supply. And so if cartilage becomes solid or calcified, then it's not going to be able to get nutrients through diffusion, and those cells will die. And so as the calcification occurs, cartilage cells die. Surrounding a cartilage skeleton, we have a perichondrium. It is the periosteum, just like the periosteum, but when it's surrounding cartilage, it's called a perichondrium. So it's still dense, irregular connective tissue that surrounds the cartilage. But in this case, as the cartilage dies, the perichondrium becomes the periosteum. And the periosteum then sends blood vessels into the calcified region. And so this produces a primary ossification center. When we have blood flowing, then we have the ability for osteoblasts to come in and start forming bone cells. And so the primary ossification center is going to occur in the diaphysis of the bone. So along the epiphyses, we still have cartilage. But just like in the diaphysis, in the epiphyses, we end up with secondary ossification centers as the cartilage cells again undergo hypertrophy and burst. This again causes calcification and death of the cartilage cells. So now we have the periosteum surrounding the bone. We have a primary ossification center in the diaphysis, and we have secondary ossification centers in the epiphyses on both sides, proximal and distal epiphyses. In the middle, we have that metaphysis, which contains a thick layer of hyaline cartilage, known as that metaphyseal plate, or metaphyseal plate, epiphyseal plate. Okay. The epiphyseal plate then is going to allow for growth in length until we hit adulthood. Once we hit adulthood, the growth of the cartilage is going to be taken over by the bone, and all we'll have left is what we call an epiphyseal line, these tiny little lines. That usually occurs, the lines will form around age 18 to 25 years of age, depending on how long you grow. So bone growth occurs in two directions. It not only grows in length, but in width. So think about a newborn baby, super tiny, adorable little pumpkin butt, right? They have very, very small bones, but they also have a very small body. So as they grow in length, their bones have to grow in length. But if their bones only grow in length, as they get bigger, they're also going to get wider, and the bones will not be able to hold their weight. And so bones have to grow in thickness as well to be able to carry the weight of a full-grown adult. So bone growth in width is called appositional growth. And so what happens is we have growth along the periosteum. Bone will be put down in a circular mechanism, so along just the edge of the periosteum. We're not producing big osteons. We're just laying extra bony matrix around the edge. But at the same time, we can't have that tiny little medullary cavity, or the bone would be too thick and we wouldn't be able to lift our bones properly, lift our body up properly. And so inside that medullary cavity, we have osteoclasts that are going to resorb bone on the inside, which causes the bone to become thicker, but the medullary cavity will also become larger. Interstitial growth is very much like endochondral ossification. So this occurs along the epiphyseal plate, and this is how we grow in length. So there are 5 different zones to the epiphyseal plate, and these different zones are going to identify what's going on. So we have a zone of resting cartilage. So this is an area where the bone isn't, or where the cartilage isn't undergoing mitosis. It's just kind of resting and waiting. Then next comes the zone of proliferation. So here's that zone of proliferation. And in this area, we're going to be growing in, or we're going to undergo mitosis. So these cells undergo mitosis very rapidly. The next area is called the zone of maturation and hypertrophy. So in this zone, we have a lot of cartilage cells, chondrocytes, that will hypertrophy, get large, and as they get large, the cartilage cells burst, causing this region to start to calcify. So down here we have the zone of calcification. So as the cells get larger and larger and larger, they burst, calcification occurs, and here we have cartilage cells die, but we now have blood vessels moving in, and we have the zone of ossification where osteoblasts will start laying down bony matrix over that calcified cartilage, basically taking over. And so up here we have resting cartilage. Down here we have bone taking over the cartilage. So as this area is growing, this area is ossifying, and eventually these two areas are going to meet and we'll end up just with this tiny little line left over, the remnants of that plate. There are some diseases associated with bone that we will talk about, or that I'm going to just mention now. One of those diseases is called Paget's disease. Paget's disease is a disorder that typically occurs in middle age. And in this disease, you have osteoclasts that are resorbing bone faster than osteoblasts can lay down bone down. And because of this, osteoblasts are laying bone really, they're laying bone down, but they're not laying it down properly. And so, because they're going too fast, the osteoclasts are working too fast, osteoblasts are trying to lay it down really fast. The bone that is laid down ends up being weaker, and you end up having more broken bones because of this. Osteogenesis imperfecta and rickets typically are seen in children. So with osteogenesis imperfecta, this is a genetic disorder in which the gene for collagen is mutated. And so there are multiple types of osteogenesis imperfecta. So it can be range from mild to very severe. And depending on the severity of your case, you may not produce collagen at all, or you may produce collagen, but the collagen is not, you're producing too little collagen, or the collagen you're producing is mutated, so it doesn't function properly. The result, though, when you have bone that doesn't have proper collagen, you don't have that flexibility in the bone, and so bone becomes very, very hard but inflexible. And what that leads to is very brittle bones. So think of a stick that is really, really hard, but there's no tissue left inside. So it's a hard stick, but there's nothing left inside that stick that's going to protect it. The stick can be broken really easily. Have you ever played sticks with your dog or something? You pick up a stick, it looks really good, it looks hard, it's like, oh yeah, this is going to be a good stick, and your dog picks it up, and with one little chomp, the stick breaks, and you're like, what the what? That's kind of like what osteogenesis imperfecta would do to your bones. The bones are, they might look good, but they're going to break super simply. In rickets, instead of the organic material being mutated with rickets, you typically have very soft bone because you don't have enough calcium in the bones. And this can be due to, I mean, there are some genetic factors that could lead to rickets, but oftentimes rickets is associated with lack of vitamin D. So we typically get our calcium and vitamin D. We can get it from the sunlight, so calcium from the sun, or vitamin D from the sunlight, not calcium. And then calcium comes from our diet. We also often get vitamin D from our diet because anybody who drinks milk, almost all milk is vitamin D fortified, because just calcium itself is not easily absorbed by our body, but vitamin D increases the ability for our body to absorb calcium. And so with rickets, if you have little calcium or a lack of vitamin D, then you're not going to be able to absorb the calcium that you do have. And without calcium, your bones are going to become softer. You don't have that calcification occurring, which causes your bones to be nice and hard. So you end up with bones that have that tensile strength, the flexibility that collagen gives, but you don't have the protection or the hardness that gives it its overall strength. And in this case, again, bones would break easier and would bend a lot easier. So here is Paget's. Here's a picture of Paget's disease from your book. Over here we have curved bones that are porous, and this kind of reminds me of rickets again, but this is typically seen in adults that are middle aged. 40 to 50 years old is when this disease shows up. Here's osteogenesis imperfecta. So here you see bone not forming properly. The osteoid isn't forming properly, and because of that, the bone ends up, the collagen that does, or not collagen, the calcium and phosphate that settle in cause the bone to be very hard, but it's not strong. And so we can end up breaking the bone very easily compared to this side. And then here's rickets, which is seen in children. So typically associated with children who lack in their diet vitamin D and calcium. And so here we have the bending of the bones again. Bones going to be much more soft, and they won't be able to hold your weight near as effectively as an individual that has enough calcium in their diet. One of the last things in this chapter is or discusses breaks in bones. A break in a bone is a fracture, and there are a lot of different types of fractures. Fractures themselves result from increased stress on bone that causes the bone to break, so snap. This could occur as we age because our bones aren't getting stressed enough, and so they're becoming weaker and weaker because stress does influence bone formation. This can also occur because we just put too much stress on our bones at one specific time, causing them to break. There are different types, like I said. A pathological fracture is a fracture that occurs because your bones are weakened from another disorder. So if you have rickets disease, and then you have a bone breakage, that would be a pathological fracture. Or if you have bone cancer and the bone breaks, that's due to a pathological, or that would be a pathological fracture. A stress fracture is a fracture that occurs due to increased stress on bones associated with increase in physical activity. So think of the shin splints, which you've probably all had before. Those are small stress fractures that form in your tibia as you are using your bones. So they're little mini breaks in the bone that are going to lead to a stronger, healthier bone in the long run. These are different types of fractures. Beautiful pictures of fractures, and here are the names of those fractures. There's a lot of fractures, but these are some of the common fractures. A closed fracture is a fracture where the bone does not poke through. An open fracture or compound fracture is one where the bone pokes through. So closed is also known as a simple fracture. Yikes, I didn't mean to do that. A transverse fracture is a fracture that occurs at a 90-degree angle to the bone. So it's just cut right down the very middle, producing a transverse plane. Why does that keep doing that? Good Lord. A spiral fracture is a fracture that spirals around the bone, oftentimes due to twisting of the bone. Comminuted fracture, like this one, is a fracture where the bones push into each other. An impacted fracture is a fracture where the bones, or an impacted fracture is one where the bones push into each other, so you had so much stress that the bones hit each other and they break. Um, Comminuted fracture is a break within the bone. I have to look that one up again. I apologize. I will do that in a second. Let me finish these two. A green stick fracture is a fracture where one portion of the breaks and on the other side it just bends. This is often seen in children because their bones are a lot weaker and thinner than adult bones. And then an oblique fracture is a fracture that is found at an oblique. So I will be right back. I will tell you what a comminuted fracture is in just one moment.